Okay, we are beginning at derivatives, and this is just an introduction to derivatives, and it's resting heavily on the ideas that we covered relating the slope of tangent from last unit. So in that last unit, we used the difference of quotient and limits to determine the slope of a tangent to a curve at a specific point on the curve. Okay, and so if you remember, we looked at the difference as the difference of h moving to 0 at a point f of a. And we do this all of the time. And because we do this so regularly, we give it a special name. And so we read this as the derivative of a function of f prime at a. So this little guy says prime at a number a is the limit as h approaches 0 as this distance between f of a plus h minus f of a if that limit exists. Okay, so connecting the derivative to the concepts we discussed in Unit 1 tells us that the derivative can be interpreted in two ways. So first we have the slope of the tangent. So that's the derivative of a function f prime of a at the point a f of a is the slope of the tangent line at that point. And that's also the rate of change. So that instantaneous rate of change of a function f of x when x equals a, and that is equal to f prime of a. So let's take a look at an example. So we have this function, f of x equals x squared plus x. And we're going to just do first at any general number a, and then we're going to plug in a value of a equals -2 and a equals 4. Okay, so f prime of a is equal to the limit as h approaches 0 of our first point, f a plus h, take away our second point, f of a. And that's all divided by h. Okay, so now we're going to consider our function and we're going to plug that in. So the first function is x squared. So I'm going to have a plus h squared plus a plus h. So this is my first term. Okay, x squared plus x. And then I'm going to take away this f of a. I'm going to put it in brackets just for clarity. A squared plus a. So that's just the function at a, all divided by h. Okay, now I just need to use algebra to clean this up. A plus h squared is actually a squared plus 2ah plus h squared plus h minus a squared minus a, all divided by h. Okay, I'm going to combine some like terms here. So I've got an a squared and a minus a squared. I have an a, and a minus a. And so after I combine those, I'm actually going to reduce the total number of terms here. It's going to look a little bit cleaner. So I really only have 2ah plus h squared plus h all over h. I can factor out an h from the top and the bottom. So I'm going to factor out an h from the top. It's going to leave me with 2a plus h, plus 1, don't forget that guy, over h. And now I can cancel out those h's. And so I'm finally just left with, as h approaches 0, so this center term is going to go to 0 as well, I'm left with 2a plus 1. Okay, that is my f of a. Okay, now that I know that, I can use that to plug in f prime at -2. Where is the function at -2? And so I do 2, -2 in the spot of a plus 1. -4 plus 1 is -3. And at, when a is 4, I'll do the same thing, put 4 into that spot, plus 1. And now I have 8 plus 1, it's 9. Okay? All right. Let's try another example. So we're going to actually drop using the a, just stick with the x because it actually didn't really need to, just kind of complicated things in that first step. If we remember when we replaced all the a's with x's, that was just kind of a complicating step. So we're going to just work from x in this example just to kind of keep things a little bit more streamlined. So f primed of x now is the limit as h approaches infinity, or sorry, it approaches 0. And here's my function. So the first part of my function is now x plus h squared minus 4x plus h. And I need to take away the function as it is. This is all divided by h. I'm going to use algebra just to expand. It's going to be x squared 2xh h squared 4x 4h negative x squared positive 4x all over h. I'm going to look for like terms. I have an x squared, a minus x squared. I have a negative 4x, positive 4x. So those will cancel out. I can write it again. 2xh plus h squared minus 4h all divided by h. And now I see, oh, I can also, I've got an h in every term, so I can cancel that out. So my derivative is 2x plus h minus 4, and h goes to 0, so it's really just 2x minus 4. Okay, and as you do this, you should be seeing that this is following a pattern every time. Let's do one more that's a little bit more complicated. We've got a rational function, so we've got something on the top and something on the bottom. So f prime at x is the limit as h approaches 0. I'm going to use two sets of brackets here. So my first term, x plus h over 3 times x plus h minus 1 minus the second term as it is, or the second f of x. This is all divided by h. I'm going to write that over here just to keep it simpler for me. Oops, sorry. Okay, in order to combine these, I need to make a common denominator. So this needs to be multiplied by x, and this needs to be multiplied by x plus h. I'm just going to distribute this. Okay. This just keeps getting messier and messier, but if we're careful, we can work it through. My first term is going to be 3x squared. Second term is going to be minus x. Then I'm going to have a 3xh, and then a minus h, minus 3x squared, minus 3xh, plus x, all divided by h times 3x plus 3h minus 1 times 3x minus 1. Okay, now I can hopefully cancel some things out. So this x squared term, 3x squared term appears twice here. And this 3xh shows up twice. And actually, so does this, negative x and positive x. So all I'm left with on the top is negative h. And on the bottom, 3x plus 3h minus 1, 3x minus 1. And now I can cancel out those h's. So the derivative of this function, as h goes to 0, is negative 1 over 3x minus, squared. Okay, some homework practice, page 75, numbers 4, 5, 8AC, 10BD. 10 is really hard, but make sure you really stick with it and get them done.